where we're going to be taking a really close look at one of the most absolutely crucial environmental situations unfolding on our planet right now. You've probably seen the headlines about this massive block of ice down in West Antarctica, called the Thwaites Glacier. And, it's earned a pretty intense nickname, the Doomsday Glacier. So our goal today is to look past all those dramatic headlines and break down exactly what the data and the latest research are actually telling us. We're going to decode the mechanics of this massive ice structure, figure out why scientists are literally racing to understand what's happening beneath it, and see what's at stake for, well, all of us.
So, the first question we've got to address, and it's a totally fair one, is this. Is the Doomsday Glacier just clickbait? The short answer from the scientific community, a resounding no. This massive 80-meter-wide formation is a very real, very urgent threat. Right now, scientists are in an absolute race against time to figure out what's happening underneath the ice. Why the urgency? Well, because the data is telling us that once this glacier truly goes, we won't be able to stop the catastrophic process that follows. It's a highly sensitive system, and it's already showing some serious warning signs.
And that leads us to a pretty terrifying reality. If Thwaites collapses, every single one of us will feel it. This isn't just some isolated event at the bottom of the globe. We're looking at a brutal initial chain of events. Just imagine huge chunks of ice snapping off and violently crashing into the ocean. That immediate displacement will push sea levels higher incredibly fast. But it gets worse. When ice disappears that quickly, it triggers sudden, violent local flooding. In extreme cases, researchers note it can even create local tsunami-like waves that are more than capable of causing some serious, immediate devastation.
And the damage builds into this massive global ripple effect. The devastation definitely doesn't stop near Antarctica. If Thwaites completely gives way, we are talking about major global hubs, places like Bangkok, Manila, significant portions of the Netherlands, and entire island nations literally starting to disappear underwater. The ultimate takeaway here? The staggering human cost. Millions of people will be forced to pack up and move. This is a massive global geographical shift just waiting to happen.
But there's also an invisible threat here. You see, it's not just about rising water. It's about what that water does to the Earth's entire operating system. If you dump massive amounts of fresh water from a melted glacier into the salty ocean, you completely mess with global currents. That disruption changes temperatures all over the world and severely impacts weather patterns far, far away from Antarctica. We could honestly reach a point where seasons just stop behaving the way they used to. And the absolutely crucial point here is that once the specific chain reaction kicks off, scientists warn it's likely entirely irreversible.
So, to understand how this could all fall apart, we've got to understand the anatomy of the glacier itself, specifically the ice shelf. Think of these shells as massive floating platforms of ice. They sit right on the ocean, but they're attached to the land. I actually love the analogy researchers use here. Think of it like a cork in a bottle. As long as that shelf, that cork, stays intact, it puts the brakes on the rest of the glacier behind it, slowing it down from rushing into the ocean. But if that cork pops out, the glacier loses its brakes entirely.
To really grasp the pressure on that cork, we have to look at the sheer scale of the environment. 136 billion tons. That number is just staggering. That is the amount of ice the Antarctic ice sheet, which, by the way, is the biggest single block of ice on Earth, is already losing every single year. The Thwaites ice shelf is jutting out from one especially fragile spot within this massive melting system. The pressure is mounting, the ice is moving way faster than it should, and it is heavily, heavily cracked. Which brings us to a major scientific paradigm shift. For a long time, researchers relied on older models that assumed ice broke in very predictable ways. Imagine snapping a clean piece of glass. Pretty straightforward, right? Well, the reality is far more complex. It turns out ice actually behaves much more like a shattered windshield, full of tiny, completely unpredictable fractures. These cracks spread in odd directions, and they're constantly changing. Because these ice shelves don't mend themselves, like once a chunk is gone, it's gone for good, scientists realized they needed a totally new approach to study these fractures before a massive break happens.
So how exactly do you study a shattering windshield the size of a country? You use ICESat-2. This is a highly precise NASA satellite that scanned Antarctica from space between 2018 and 2024. It is an incredible piece of tech. It tracks these tiny little changes in the height of the ice to see how the surface shifts. Using this data, researchers can literally slice through the ice digitally, creating detailed cross-sections. They're essentially taking X-rays of the ice shelf, allowing them to do some critical detective work. For the first time ever, they can watch exactly how deep fractures grow, spread, and connect right beneath the surface. Now, the crucial part is what those X-rays actually revealed. When scientists looked closely at the Thwaites ice shelf, they found a really stark contrast. The eastern side of the shelf is highly fractured and broken up, while the western side remains relatively stable. Scientists are still piecing together exactly why the split exists, but the leading theories point to a combination of warmer winters, a lack of the sea ice that normally protects the shelf, and changing ocean currents flowing underneath the eastern side, basically eating away at its structural integrity.
Understanding these vulnerabilities is absolutely key because big ice sheets in places like Antarctica and Greenland are incredibly sensitive to warming. When they fail, it isn't random. Researchers have found that these giant structures generally succumb to warming temperatures in 3 specific ways: sliding, ice cliff collapse, and surface melting. So let's break down each one really quick so you can see how this collapse actually plays out on a structural level.
All right, threat number 1, the sliding problem. Here's what happens. Warm ocean water sneaks in and eats away at the ice from below on downward sloping ground. This causes fast-moving glaciers, like Pine Island and Thwaites, to basically slip and slide much faster right into the sea.
Then we have threat 2, the ice cliff chain reaction. When these shelves break, they leave behind these massive 30-story frozen cliffs, and they just cannot support their own weight. Meltwater pries open the cracks, the cliffs collapse, and that creates taller, even weaker cliffs behind them.
And finally, threat 3, the surface melting loop. And this brilliantly illustrates the whole problem. As the ice melts on top in places like Greenland, the surface of the glacier physically lowers down into warmer air, which just speeds up the melting from the top down in a relentless, vicious circle. Now, if you're wondering how fast a collapse can actually happen once these threats take hold, we have a very real, very sobering historical precedent, the Larsen B ice shelf. This was a massive platform of ice, about 1,250 square miles. To put that in perspective, that's roughly the size of the state of Rhode Island. For years leading up to 2002, it was secretly weakening from warmer water. By early 2002, the warning signs were there, but older models completely missed them. Then the tipping point hit. It took just 5 weeks for that entire Rhode Island-sized shelf to shatter and vanish. It is a terrifying cautionary tale for Thwaites today. So, what does this all mean for us right now? Let's ground this threat in the current data. Based on the latest models analyzing these accelerating flow rates, we are looking at significant sea level rise within our lifetimes. By the year 2100, sea levels are already projected to rise anywhere from a minimum of 1 foot to over 5 feet. That massive variance, it completely depends on whether these changes start feeding on themselves and speeding up the ice loss, exactly like we saw in those threat loops a minute ago.
But scientists are also looking further down the timeline, running those worst-case scenario models. And that brings us to the year 2300. Some computer models warned that massive ice loss in West Antarctica in less than 300 years could cause disastrous worldwide coastal flooding by 2300. We'd be looking at an entirely different global map, permanently altering life around the globe.
But hey, despite these heavy numbers, the narrative here isn't just about doom and gloom. It is about intense, focused preparation. Because the clearer the picture gets, the better chance we have to reduce future damage. Researchers are taking all that missing 3D data they finally have, and they're building a gigantic map of fractures across more than 40 different ice shelves to spot those warning signs early. They are actively hunting for the tipping points before the big break happens.
Which leaves us with a pretty provocative thought. Will we actually map the tipping point in time to save our coasts? The tools are better than ever, but the ice is changing incredibly fast. Understanding the Doomsday Glacier isn't just some scientific exercise. It's a desperate race to predict these failures and avoid the displacement of millions.